Okay, having a little technical difficulty here. There we go. Okay, so I have had a request, at least as I understand it, to sort of go through the insert function again to see how the list gets built up. Maybe I'll do it twice. Let's so ignore this picture up here. Let's start a new picture. So when I first declare, if in my client code I declare a simple list object, I just realized that in my client code I used the word list here. Probably would have been better to use something different because that's also the name of my data member. In fact, I might actually change that. Bear with me here for just a second. If I can. Isn't what I wanted to do. All right, let's just do this. List. That turned out to be more than I would have guessed. And we're still going. Okay. So hopefully that'll be worth the 60 seconds or so it took in order to just make sure everything is crystal clear. Oh, change this one. Okay, so over here, when I say list, I'm talking about the data member. So it might actually make, what I could type here is I could type mylist.list, right? Because the actual variable object that I'm declaring is mylist, and list is one of the data members of mylist. So when we first declare mylist in the client code, the constructor gets called, and what the constructor does is it initializes mylist.list to null pointer. So it would look like that, right? So then we get into our while loop and I start inserting numbers. So let's say the user enters a 1. So I'm going to insert a 1 into my list. So I go over to my insert function. I just noticed this as a. So go over to my insert function. And the process there is declare a new node. Well, declare a variable here, a pointer variable named new node on the stack. Oops. And then make it point to a newly allocated node on the heap. Right, so that's the first statement in the insert function. Then new node arrow data gets the item that was entered, so that's a 1. New node arrow next gets list, but list is null pointer, so that means that new node arrow next is going to get null pointer. And then list gets new node. And so there's how we insert the first item into our list. Any questions about that? Anyone want to say that's still really hard, or that's really clear now, or? Nope. Okay. So let's go ahead and say that we are going to insert another item now, right? So we're going to insert a 2 now. Obviously, between function calls, new node was a local variable inside the insert function, so it goes away. But then the next time we call insert, it comes back. So I'm just going to leave it there. So I'm calling the insert function with item equal to 2 now. So I create another new node. Allocate is the word I should use. I allocate another new node. And I make new node point to it. Okay, so that's the first line. New node arrow data gets item, which is now 2. New node arrow next gets list. So new node arrow next is this box right here. And that line says, let new node arrow next point to the same thing that list is pointing at. So that's going to be this. All right, so the 2 is now pointing at the 1. By the way, when I say the 2 is pointing at the 1, I'm speaking very loosely, right? I should say the node that contains the 2 is now pointing at the node that contains the 1. In fact, I should say the next data member of the node that contains the 2 is now pointing at the node that contains the 1. But it's easier to just say the 2 is now pointing at the 1. Okay, so where were we? We did the new node arrow next gets list. So now I say list gets new node. So here's list, make list point to the same thing new node is pointing at. Like that. So now I'm done with my insert function, and my list is, if I start with my list.list and follow the arrows, my list is now 2 and then 1. Okay. Anybody want to vote on whether I insert one more time? And let me rephrase that. If anybody wants me to insert the node another node one more time, I'm happy to do that. But it's basically going to be exactly the same thing, just a 3 going to go here. Okay, excellent. Okay, so I guess I'm going to leave this picture here. Hopefully it won't get in our way. If it gets in our way, I'll have to delete it later, but just ignore this now because we're going to go back up here. And we're going to be working on our find function. What if the destructor fails? Do you mean constructor? If the destructor fails. So if there's a memory leak, that's not going to affect the execution of our program at all. It's just going to mean that we're wasting memory. Chat. Okay, I'm not sure I'm totally tracking with the question, but I think that's the best I can do for an answer at this point anyway. Okay, so we're going to write a find function next. Before we do that, there's something I want to do. In the lesson, I actually have a value type. And I think I'm going to go ahead and, no, you know what? I'm going to leave it at int for now. I'm going to switch it to value type in a minute. Sorry, I'm kind of talking to myself here, but okay, so looking at the client, let's look at what is expected from our find function. We see that the find function, what it's supposed to do is it's supposed to find the first argument here in the simple list object that is the calling object. So I'm going to find this first argument in my list, and I'm going to return that value so that result is going to get set to that value. There's also a second argument, and that argument is going to have to get set to false if I did not find what the first argument. If that first argument is not anywhere to be found in my list, then found is going to get set to false. Otherwise, found is going to get set to true. So what that means is that from the perspective of the client programmer, if I call the find function, and after I call the find function, found is equal to false, then the value, the return value of the function is undefined. I shouldn't be using it, right? Because I didn't find anything, so there wasn't anything to return. Any questions about what we're trying to do here? Let me just make one more comment about that. It sometimes seems kind of silly to students because what we're doing is we're looking for, let's say, for example, we're looking for the number 19. And so we find the number 19, and what do? We return the number 19. So that's not very exciting. What you have to imagine is that normally a linked list would be a list of something much more complex, maybe something like maybe a linked list of employees, say. And what I would be looking for would be, I would be looking for employee numbers, perhaps, maybe even employee names. But then what I would return is I would return the entire employee object, which might include their address and their position and their pay rate and things like that. So obviously I wanted to keep this simple and not get into all of that, but sometimes that confuses students because they're like, well, why are we even doing this? If all we're doing is returning what we're looking for. All right, hope that made sense. Any questions about that? So should we default the bool to false until we find what we're looking for? That would be one. That'll be one approach. Yeah, I don't have a problem with that. It's not the approach that I took. I basically just set it to either true or false at that point, at the point where I found it or didn't find it. But I think, yeah, either way would be fine. Okay, so let's work on our find function. First, the header file. Need to add it here. So it's going to return an int because what we're doing here is we're creating a simple list where the objects in the list are ints, right? The name of the function is find, 2 arguments, int, because that's the type of the objects that are in the simple list. Okay, any questions about the header or the prototype? Okay, actually it turns out this should be const. All right, so let's go to our implementation file. Yikes. Return type is int. Name of the function is simple list : find int item found const. Okay, so there's actually a couple different ways to write this. In fact, I provide 2 different versions of it in the lesson, just in case you're interested. The beginning and the function declaration. Okay, so what's the difference between putting const at the end or const at the beginning? Well, do you mean the beginning or do you mean inside the parameter list? Because at least in our lectures and in the notes, we have, oh, you mean in the parameter list? In our lectures or notes, we've never put const in front, right? But okay, sounds like the question has been answered. All right, I'm going to go with that. So go over why having it at the end means sorry. Yes. Just I don't not to pick on anybody, but just to be sure we're clear, this was lesson 15.7, I think, or no, 15.9, very first lesson on classes, right? So in case you need to go review. But basically just means that the calling object cannot be changed, right? So when we call find, the calling object is that list, right? And so what we're saying is that I'm just looking for something in the simple list object. I'm not going to change the simple list object. Okay. All right. So one way of looking at this, and in fact, actually the way that is most instinctive for me is to set my while loop up so that I can look at the heading of the while loop and know exactly when it's going to stop executing. So gonna back up for a second here. Let me tell you the basic strategy. The strategy is we're gonna create another pointer and we're gonna make the pointer point at the first item in the list. Then we're gonna have a while loop where we check to see if that item is what we're looking for. And if it's not, we're going to move that pointer so it's pointing at the next item in the list, next node in the list. And we're going to check to see if that's the item we're looking for. If it's not, then we're going to change that pointer again so it's pointing at the next node in the list, and so on. So that's the idea. My first, we're going to need, as I said, we're going to need a new pointer variable. Let me call it cur pointer. And I'm going to start it off pointing at the first item in the list. So that looks like cur pointer. Let's steal arrows from down here. Pointing at the same thing that list is pointing at, which is the first node in the list. Okay. And then my instinct would be to say, I want to keep going until one of two things will make me stop, right? I can stop. I want to stop if I find what I'm looking for, but I also want to stop if I reach null pointer. So I could say something like while cur pointer not equal to null pointer, and also cur pointer arrow next not equal to what I'm looking for. All right. And then I would just keep advancing until one of those two things happened. And then after the while loop, I would have to have an if statement to figure out which of those two things made the while loop stop. So not sure why I felt compelled to show you the two different ways to do it. But it turns out that the alternate way of doing it is a little bit simpler. What we're going to do is we're just going to say, set up a while loop that goes all the way through the linked list. And then if we find what we're looking for, we're just going to stop and return. Okay, so if cur pointer arrow data, I have this feeling like when I typed it before, I said arrow next. Should have been arrow data. If cur pointer arrow data is equal to item, that means we found what we're looking for. So set bound equal to true and return cur pointer arrow data. Okay. Otherwise, we're just going to move cur pointer down to the next node in the list. Cur pointer gets curve pointer arrow next. Okay, this is a super, super common statement. You're going to see this a million times when you're doing your lab, and especially when you go into your data structures class. So just make curve pointer point at the same thing that curve pointer arrow next is currently pointing at. So curve pointer arrow next is pointing at this node that contains the 19. So this assignment statement is saying make curve pointer point to this node that contains the 19, right? So move it, in other words, advance it one item in the list. Okay, so then we go to the top of our while loop. Curve pointer is still not null pointers. We check to see if the node we're looking at is equal to the item we're looking for. If it's not, then curve pointer gets curve pointer arrow next, and now we're looking at this node, and so on. Okay. So the last thing we have to do is if we make it all the way through the while loop, that means we didn't find what we were looking for, right? So that just means found gets false, and then return. What should we return? So the problem here is we have to return something. But what we return is undefined, right? From the perspective of the client, they're not supposed to depend on this return value for anything because found is false. So what we typically do in that case is we return the default value for the type of object that we are returning. And I'm going to introduce kind of a tricky, so one way, so the default value for integer is 0, so I could just say return 0. Okay. But there's another syntax that we could use, which is might be new. I can't remember, but I could just call the constructor for the int type. Oops. Like that. What this does is this is calling the constructor for the int type. Okay, right, yes, thank you. You have seen this syntax. We're calling the constructor for the int type. It's creating an int using the default constructor and then returning it. Okay, so the only reason I would want to do this instead of just returning 0 is because I'm trying to stay flexible in case I want to change the type of the items that are contained in the container to something different. It'll be easier if I use this general way of saying it instead of just saying return 0. That makes sense to everyone? Any questions about that? Okay. Where can we learn more about the int? My answer to that question is I don't know. But honestly, I'm not, I think I've told you everything there is to know about it. So you may just need me to say it again or say it a different way or something. It may start to make a little more sense after we do the next thing we're going to do. So if you can think of a way to articulate a question you have about it, happy to talk about it more. For now, I would just say if you understand that it's return, that just means return 0, we're good. Okay, so I think we're ready to test this. All right, let's see how it goes. Usually like to make this a little bigger. So where I am, yeah. Okay. So I'm going to just insert a bunch of numbers. Then I'm going to quit. And now it's asking me to find numbers. So if I look for the 1, it's there. If I look for the 2, it's there. If I look for something that's not there, it tells me that it's not there. Okay, so it looks like it's doing what we intended. Any questions about the find function? Okay, the next thing we're going to do is I'm going to digress a little bit instead of just going on to the next function, which would be the delete function. And I want to fix this problem we have of we want to make this a little bit more general so that in case I want to use other types instead of int in the container, it's easy to make that change. So I'm going to do that by introducing this value type. Okay, I'm pretty sure we've seen this before, right? I think we saw this in the templates assignment. Any question about what's going on there on that line? I'm just saying from now on, when I say value type, that means int, right? And so we're going to go through our code, and every time we see int being used as the type of the items in the container, we're going to put value type there instead. And then later on, if we want to store feet inches objects or inventory item objects instead of ints, we can just change it in one place right here because it's going to say value type everywhere else. Okay, so let's look at where we need to change it. We should change it here. We should change it here. We should change it here. You can't just search and replace, by the way. At least you can't do it like search and replace all, because there may be some places where you're using int for something other than the type of the values in the container. Although in this case, I'm kind of thinking that we could have, but size, print, find. What we're returning is value type, right? Okay, and then so right here, maybe this is the most interesting part. Now I have an expression that's going to work no matter what value type is, right? So if value type is inventory item, what I'm going to return here is I'm going to call the constructor, the default constructor for the inventory item class, create a default inventory item and return that. Okay. Any questions about all the stuff I just did? Okay. Then I think we're ready to move on to our del function. Going back to our client. Here's the part of the code that tests the del function. Why would I call it del instead of delete? What did I do wrong there? Something's wrong. Oh, wrong way. Duh. Right, delete is an operator, to be technical, but yeah, delete is a word that we can't use because it has another meaning in C++, so it cannot be used as an identifier. Does that answer your question, William, or is that still a question? Because I'm not sure what. Okay. Okay, so the del function is actually an awful lot like the find function in terms of the format and having 2 arguments and a found argument. All that's going to be the same. The only difference is that when we find it, we're going to actually delete it, right? If you're thinking hard about this, your first instinct might be to say, well, let's use the find function. And then once we find it, all we have to do is delete it. And we don't have to actually write the code in the del function to find it. The problem is that our find function just returns the value. It doesn't return the location. So it turns out that that's not really going to help us. We're just going to have to write the del function from scratch. Okay, so prototype. The del function is void, right? You can tell by the way it's called. And let me just re-emphasize, if I give you a client program and tell you to write the program, you can always tell exactly what the prototype's going to be just by looking at the function call, right? I'm looking at that function call and I see that is not a value returning function. That's a void function. Anybody want me to say more about that? Okay, so and we've got a value type for the first argument, and we've got a bool for the second argument. And this is not const, right? Because we're actually changing the simple list. Oh, I just, whoa, what am I doing? Sorry. Realized something else that I forgot. And that is that now that this is a more general term and value type might be an object, I shouldn't pass it by value, right? So when I was changing all of the inst to value types, during that process, something else I should have done is I should have changed the parameters to be const ampersand instead of pass by value. And then it's going to be the same thing in the del function. Any questions about that? Find function should also be value type. Yes, it is. In the find function itself doesn't. Oh, thank you. Thank you. Yes, you're absolutely right. It should return a value type. Thank you. Good catch. Okay. Wow, totally missed that one. Right, let's write our del function. Okay, so del is going to start off an awful lot like the find function. Except in this case, once I find it, there's a lot of other stuff to do. So I'm kind of thinking, well, all right, I'm going to do something which is, I always regret it when I do it, but I'm going to give it a try anyway. I'm going to veer from my notes just a little bit here because I think there might be a better way to do this. So we'll find out if I'm wrong. It'll be a learning experience. So I'm going to do the same thing I did. Well, okay, let's look at the picture a little bit. We need to stop and think about this. So let's say that, let me get rid of this for now. Let's say that I want to delete the 19. What is going to have to change in my picture in order to delete the 19 from my list. $47 has to point at 62. Exactly right. Everyone, that makes sense to everyone? I'm just going to say, make this guy point up here. Done. Right? I mean, there's some details there. I should deallocate this node so it's not a memory leak. But essentially, just changing this one pointer is all I need to do. Yes, I will. The details are going to be, I'm going to have to temporarily point something here at this node so that I can delete it after I have reset this pointer. Okay, so let me make an observation about this. What that means is I don't want in my del function, when I am looking for the node I need to delete, once I find it, what I want is not a pointer to that node. If I am trying to delete the 19 and all I have is a pointer to the 19, can I delete it? The answer is no, because what I need is a pointer to the node before the 19, because this next data member is the one that needs to change. Okay, so in order to delete a node from a linked list, what you need is a pointer to the node before the one you want to delete. Hopefully that makes sense. So that's going to make our while loop a little different than it was with the delete function. All right, let me get rid of this now. So here's what we're going to do. I'm going to call my pointer prev pointer. And I'm going to start it off pointing at the first item in the list. So as we're going through this process, anytime you think of something that seems kind of problematic, feel free to throw it out in the chat, because there's some interesting issues that are going to come up here. So this is now, we're calling it prev pointer instead of cur pointer, and we're starting off with it pointing at the first item in the list. Everyone okay so far? All right, so what I'm going to do next is I'm going to go ahead with my instinct, which is to just set my while loop up so that it goes until either I find what I'm looking for, or I reach the end of the list. Okay, but it's going to be a little tricky because prev pointer is pointing. So what I want to be checking is I want to be checking whether prev pointer arrow next is what I'm looking for. Does that make sense? Because I'm not looking for the node with the 19 in it. I'm looking for the node before the node with the 19 in it. So I'm going to be checking to see whether prev pointer arrow next arrow data is equal to 19 or whatever it is I'm looking at. Any questions about that? Anyone want me to say it again? So I'm going to say while prev pointer arrow next is not equal to null pointer, and prev pointer, it's kind of weird that, yeah, never mind. Prev pointer arrow next arrow data not equal to delete me. Okay, and then inside here, I'm just going to say prev pointer gets prev pointer arrow next. Okay, I think, will this, can you still see this okay if I make it a little smaller? Anybody prefer that, strongly prefer that I make it bigger? Because it'd be nice if we could see the whole diagram here. Actually, I can move this a little bit too. All right, if there are any requests for making it bigger, feel free to let me know, and I'm happy to do that. Okay. Yes, I will. I will definitely go over this. By the way, I just want to say you could send me a private chat if you don't feel comfortable telling the whole class that you want it bigger. Okay, so let's take a look at this in a little more detail. This is saying while prev pointer arrow next is not null pointer, which makes sense, right? Because if prev pointer arrow next is null pointer, like if prev pointer is pointing at the last node in the list and prev pointer arrow next is null pointer, then I'm done, right? It means what I was looking for is not in the list, because if I was looking for the 62, I would have found it when prev pointer was pointing here. Okay, so that's why I say while prev pointer arrow next not equal to null pointer. And then prev pointer arrow next arrow data, what does that mean? So let's say, for example, prev pointer is pointing here. Prev pointer is this pointer, right? Prev pointer arrow next is this pointer. So prev pointer arrow next arrow data is the 19. Any questions about that? That might be a little tricky to think about the first time you see it, but this is something that will become second nature really quickly. Every time you just see the arrows here, you just follow that. That just means follow the arrow to the next node, right? Okay. Any questions about this loop? So when I finish this loop, there are two possibilities. Either delete me is not in the simple list, or prev pointer is pointing at the node before delete me. That makes sense to everyone? I'm demonstrating excellent programming here, right? I am stopping and I'm reasoning about what I know at this point in my code, and I'm actually typing it out. At this point in my code, one of those two situations must be true. And what I have to do next is I have to have an if statement that figures out which one, right? So I want to say, if delete me is not in the simple list, how can I say that? Can I write an if statement that says that? If delete me is not in the simple. How would I say that? If delete me is not in the simple list, that means that what's true about prev pointer? Okay, that's actually correct. I could say if prev pointer arrow data is not equal to delete me. That would actually work fine. Another option would be to say if prev pointer arrow data is equal to null pointer, right? Because if delete me wasn't in the list, then where I stop is I stop with prev pointer pointing at the last node in the list. So prev pointer arrow next would be null pointer. So either one is fine. I have a preference for checking null pointer. I'm not sure why exactly. just my instinct, so I'm going to go with it. So if prev pointer arrow next is null pointer, oops, then all I need to do is say found gets false and I'm done. Right? So then I need to handle the other case, which is prev pointer is pointing at the node right before delete me. Okay, so in this case, it's kind of, this would actually, sometimes I feel like I need 4 or 5 nodes here to make it work a little better. But right now, prev pointer is pointing at the node before what we want to delete. I'm just, as an example, I'm saying, let's say we want to delete the 19. Notice what I'm doing is, this is a side point, but what I'm doing is I'm writing this code as if I'm deleting something in the middle of the list. And the reason I'm doing that is because I am, in the back of my mind, I'm thinking, okay, if I'm deleting the first item or the last item, that may turn out to be a special case. I'm not sure yet, but right now I just want to work on the general case. And that would mean, you know, the list has a lot of nodes in it and I'm deleting something somewhere in the middle of the linked list. That's the general case. So let's keep working on that. So I'm going to say found gets true. I'm going to set up a temporary pointer to point at the node that I'm deleting. So node star temp pointer gets prev pointer. I'm not sure why I capitalized the P in prev pointer, but in nothing else. Prev pointer arrow next, right? So I am creating a new node named temp pointer. And no, sorry, let me say that again. That was wrong. I'm creating a new pointer on the stack named temp pointer. And I'm making it point to prev pointer arrow next, which is this node here, right? Make it point to the same thing that prev pointer arrow next is pointing at. Okay, so that's what that statement does. And the reason that I'm doing that is so that after I move this arrow and make it point to the 62, I can, I still have a pointer to the node that I want to deallocate. Isn't there a case where prev pointer arrow next is moved at prev pointer arrow data equals delete? No, because if prev pointer, that's a great question. The question is, isn't there a case where prev pointer arrow next equals null pointer? Let me actually, that's a great question. So I'm going to actually work on that a little bit. I think this is set up so it won't let you copy paste from the chat. Very interesting. Isn't there a case where next equals null pointer? Okay, there's the question. The answer is no, because if, in this case, that would mean that the last item in the list was delete me, right? But if the last item in the list is delete me, then our while loop is going to stop when prev pointer is pointing at the 19. So I'm never going to get to prev pointer arrow next gets null pointer. How'd I do? Want me to say that again? Okay, so does everyone understand that? Yeah, we check prep pointer, arrow next, arrow data. Exactly. So everyone understand the question? The question is prep pointer, arrow next equals null pointer. Could it be the case that prep pointer, arrow next equals null pointer, but prep pointer, arrow data equals delete me? So in other words, I would want to delete the item that prep pointer is pointing at. The answer is no, because we would have stopped our loop when prep pointer was pointing at the 19. If we were deleting the 62, which is the only possible time this could happen, right? We're deleting the last item in the list. When prep pointer is pointing at the 19, prep pointer, arrow next, arrow data is equal to delete me, and so the loop stops. So we never get to the point where prep pointer, arrow next is null pointer. I understand that sentence had like just a ton of buzzwords in it. So if that is not clear, I think I'm going to say it's okay. You know, it's probably okay to just move on, because that was just really complicated. The other option would be to go look at the recording. Yes, the loop is always looking one node ahead to find delete. Okay, so let's get back to this, okay? 10 pointer gets prep pointer, arrow next. So I made 10 pointer point to the node that we want to delete. Now I need to make the 47 point at the 62, right? So that means prep pointer, remember prep pointer is pointing at the node before the one we want to delete. So I want to make prep pointer, arrow next point to what? The 62. How do I say that? I want to make it point to the same thing that this pointer is pointing at, right? And what is this pointer? This pointer is prep pointer, arrow next, right? Okay, so what that statement does is it makes this pointer, which is prep pointer, arrow next, point to the same thing that this pointer is pointing at, which is prep pointer, arrow next, arrow next. So that statement says this. Okay, so now we've got our list set up correctly. List is pointing at 47, which is the first item, and then the 47 is pointing at the 62, which is the second and last item. Now we just need to deallocate this node. So we say delete temp pointer. And that would make, you know, I could erase this. Erasing isn't actually what happens. What's really happening here is we're saying, okay, this has been deallocated. You can use it for something else now if you want, right? Okay, any questions about the del function? All right, so this is where something I said on Monday is going to come into play. On Monday, I said, whenever you write a function that involves linked lists, after you're done writing it for the general case, you're going to have to think about what all of the possible special cases should be, or boundary cases should be. Does this work if I'm deleting the last item in the list? Does this work if I'm deleting the first item in the list? Does this work if the list is empty? Does this work if the list only has one item in it and I'm deleting that one item? And that would take a while, right? You're just going to have to ask yourself all of those questions. Let me ask this first. Is this going to work if the list is empty. That's usually the most fundamental, basic special case that you need to check for. What's going to happen if I get to this function and the list is empty? Someone want to tell me what's going to happen? Right, prep pointer doesn't have a next. So when I get right here, my program is going to crash. It's going to say, you tried to dereference a null pointer. That makes sense to everyone? Okay, so what that means is this whole thing is going to have to be in an if statement. I'm going to say if list equals null pointer. If the list is empty, then all I do is just say found gets false and I'm done, right? Else, all this stuff. Any questions about what I just did? Pretty straightforward fix, right? Not a huge deal, but you just have to check all the special cases, all the boundary cases. Well, because if we use assert, then that means that no matter, it's better to tell the client programmer, because the client programmer may want to write a program where sometimes she calls the del function, even though the item isn't there. That may just work better, and they may just want me to tell them that. If I use assert, then every time they call del with something that doesn't exist, the program just crashes, right? And then actually what we should do here is we should use an exception, right? Yeah. So if I was really doing this thoroughly and correctly, we would use an exception here. This thing with having an additional parameter that returns true or false is, I would say, a little clunky, right? But to be honest, the reason we're doing it this way is because in the past I've taught this before we got to exceptions. So this is what we're doing. Okay. Anybody want to suggest another boundary case we might want to look at? So how about this? Let's go back to our original picture here. Well, if prep pointer arrow next does not exist, that would be the situation if we were deleting the last item in the list, right? So that's an excellent question. But basically what you're asking there is, does this work if the item we are deleting is the last item in the list? Does that make sense why that's what you're asking? That's another good question, Joseph. We'll get to that in a sec. But so the first question is, does our code work if the item we're deleting is the last item in the list? So let's get things back to our original picture here. I'll leave temp pointer sitting there, even though it's not actually there yet. And then we've got, this should be pointing, whoop. This should be pointing. I think that's it, right? And then we should have a null pointer in. Okay, so the question is, if we're trying to delete the 62, what our loop does is it stops when prep pointer is pointing here, right? So let's trace this through. set found to true. Temp pointer gets prev pointer arrow next. So temp pointer's now going to point at the 62, which is good. That's what we want to delete, right? Whoa. Yikes, that's getting a little scary there. Hopefully you can see everything going on there. So that's temp pointer gets prev pointer arrow next. And remember that temp pointer is just there so we can delete this node. And then we say prev pointer arrow next gets prev pointer arrow next arrow next. What's prev pointer arrow next right now? Null pointer, exactly. Prev pointer arrow next is here. Prev pointer arrow next is here. And it's just null pointer. Okay, so what we're saying is let prev pointer arrow next be null pointer, which, as it turns out, is exactly what we want, right? Because now the 19 is going to be the last item in the list. Okay, and then we delete temp pointer, so the 62 node goes away. So, excellent question. That's definitely something that we needed to check. We checked it. It turns out that that situation falls under the general case. Okay. Let me get this back to where we started from. All right. We're a little short on time, so I'm just going to tell you what the other boundary case that's actually going to be an issue is. Let's see, someone asked where there's one item in the list. It actually turns out that the other problem is a little more broad than that. I mean, that's a great place to start. We should check that, and you're correct, it doesn't work in that case. But the actual issue is anytime that we are deleting the first item in the list, right? So let's say that item is 47, and let's trace through our code and see what happens. So item is delete me is 47. So list is not null pointer, so we have prev pointer pointing at list. Yeah, exactly. We can't, there's no node before the 47 to point at. But let's trace through the code, okay? We set prev pointer equal to list. Then inside our while loop, we say while prev pointer arrow next is not null pointer and prev pointer arrow next arrow data is not delete me. So neither of those is true. So we advance prev pointer to the next item. So the issue is that we never actually look at the first node in the list. We just skipped over it, right? And what would happen in this case is that we would, the function would think that the item didn't exist in the list and it would just set found to false. Okay, so got another special case. Let's take care of it. So else if list arrow data, in other words, the first item in the list is equal to delete me. Then that just means make list point to the second item in the list, right? List gets list arrow next. So we don't even need to, okay, I'll just do it. Right? So that actually successfully deleted the 47 from the linked list. That's all there is to it, except now we didn't deallocate the node, so we have a memory leak, right? So we just need to do the same temp pointer thing that we did down below. Ooh. In my experience, it doesn't really make sense because they're just like 1 or 2 lines each time anyway. I think it ends up just convoluting things more. But I haven't spent a lot of time trying it. So I wouldn't stake my life on that. Node star temp pointer gets list gets list arrow next, and then delete. And then also we need to say found gets true, which just to be consistent, we'll do at the top here. Okay. Because yeah, I mean, the function you're referring to, Joseph, would have to somehow take parameters that, I guess you could write a function that did those 3 lines, right? So that might be worth playing around with a little bit. But I don't think it would be a huge win. I think this is pretty easy to look at. All right, good. I want to make sure everyone sees the note in chat from Kyle about lab. There's no lab tomorrow, so you're welcome to join tonight's lab, 4 to 7 p.m. And there's a link there. I guess you are going to have to copy and paste that link right now if you want to go to that lab. Is that right? Or is there another place to find that link? I guess it doesn't matter. Just everyone. Oh, you can't copy paste, can you? All right, good. Kyle's going to post a Canvas announcement with the link, so you don't have to worry about the link. All right, so I think we're done here. Maybe we should just give it a quick whirl since I've got 60 seconds left or so. Yeah, I thought so. Oh, right. Here I need to say simple list : value type. Well, I think that's also there, but I don't doubt that I also wrote a comment without the comment syntax at the bottom of simple list.cpp. Thank you. One more try. Yes. So I'm going to just insert a bunch of numbers, quit. I'm not going to find anything for now because I'm testing del. Enter a number to delete. Let's put in 2. That worked. Let's make sure to test it when we're deleting the last item in the list. That seems to have worked. Let's make sure to test it when we are deleting the first item in the list. That seems to have worked. Let's make sure it works when we're deleting something that's not in the list. That seems to have worked. Let's go ahead and delete the 4. So now we're going to check to see if it works when there's only 1 item in the list. First, something that's not in the list, that works. For now, delete the 1 item in the list. That works. And now if I try to delete from an empty list, that works too. Okay. So we're done with delete. I think you have enough that you could get a pretty good start on the lab that's coming up. The only other thing we have to do with our simple list class is we're going to add the big 3, because right now, if I do I can break my class pretty easily if my client program uses assignment or copy. All right, that's it for today. I hope you have a good lab, and I will see you on Monday.